La Pasarela de la Paloma is a pedestrian footbridge crossing over the M30 highway in the northeastern region of Madrid, Spain. Completed in 2010 at a cost of about €3 million, it is a steel girder bridge composed of multiple truss sections. During the 1960s, Madrid and the rest of Spain experienced considerable industrialization and an extraordinary economic boom. A large migration of people from the rural regions surrounding Madrid into the city soon followed. This massive inflow of workers was matched by a steady increase in automobile traffic throughout the city. In order to improve vehicle movement, construction began on the M30, a multi-lane highway that would serve as the innermost ring road around the central districts of Madrid. While the highway provided drivers with an alternative to city streets, it became a barrier to pedestrians attempting to reach the urban center. La Paloma Footbridge was designed by Peter Tanner, Juan Luis Bayod, and David Sands of Sesma Engineers. The bridge has a total length of 191 meters distributed over 4 spans, and consists of steel truss members and a composite concrete and steel slab. The most unique aspect of this bridge is its form, a result of various constraints in the project site.
The local government, they told us, okay, you have to make a bridge here, somewhere on this portion of the road, but please look for the best place. So we have chosen this place because on the other side we have a metro station of the underground, and here we have an office area, so in the morning quite a number of people are coming to their work and are using this bridge.
Connecting the districts of Chamartín and Ciudad Lineal, the design of the bridge needed to meet an 8-meter rise in elevation, maintain a 6-meter clearance above the highway, and accommodate accessibility with a gentle 4% slope. To achieve this, the engineers decided to cross the highway with a curved structure. The curve elongates the bridge and allows for a less steep change in elevation from one side to the other. A curved bridge requires special consideration because the center of gravity of the structure does not fall on the line connecting the abutments of the bridge. This eccentricity results in an overturning motion of the bridge towards the outside of the curve. Two characteristics of the bridge that oppose this overturning motion are the C-shaped cross-section and the 3 Y-shaped piers between the spans.
So under the self-weight, it goes the other way around. Okay? So in order to avoid that, what do we need? We would need a vertical force here, for example, but showing to the bottom. Yes? Yeah. So you have to transmit actually negative reaction forces. Or you can also have a horizontal force here on the top of the branches of the Y-shaped columns, for example, and showing the other way around.
The C-shaped cross-section of La Paloma is composed of 3 steel trusses, one in the top flange, one in the bottom flange, and one in the web. Acting as an open cross-section steel girder, the shear center of the section sits outside of the C, while the center of gravity sits inside the C. This eccentricity results in an overturning motion of the bridge towards the inside of the curve, opposite the rotation due to the overall curvature of the structure. The Y-shaped piers are integrated into the web of the cross-section and provide horizontal reactions to the top and bottom flanges. This resists the overturning motion towards the outside of the curve, but also introduces moment in the piers. While the constraints of the project presented challenges in the design of La Paloma, they also required additional examination of the construction process by the structural engineers.
Yeah, actually it was pre-assembled on the other side of the road. Then it was put on towers which rested on a self-propelled modular trailer. And during a nighttime operation, the different spans were brought to their place and then supported on provisional supports in order to be able to take away the modular trailer and to open the motorway again for the traffic.
Overall, the construction and assembly process was very efficient and helped to minimize the cost of the project. In the words of the structural engineers, particular effort was made to translate the many conditioning factors into a functional, elegant, innovative, and at the same time cost-effective structure. La Pasarela de la Paloma successfully meets this goal and is exemplary of the aesthetic and inventive aspects of Spanish bridge design.